Hello everyone and welcome back to my channel. We're going to be talking about quotient rule, not product rule, but quotient rule only. So, something that you need to know is just like with product rule, when we have two things that are being multiplied together with variables, we need a special rule for when we have two things that are being divided by with variables. So that thing is called quotient rule. Quotient rule and product rule are named that way because a product is two things that are the answer to a multiplication problem, while a quotient is the answer to a division problem. So just like before, we have two different ways that we can write this, but this time because of division, we have to worry about a specific order. So if we look at our u and v version of this, we would have u prime times v minus v prime times u, all divided by our original denominator's function squared. So u prime times v minus v prime times u, all divided by v squared. This is going to look really similar, to product rule. The big differences is we have division and we're dividing by v squared, and instead of addition we have subtraction. We can look at it with f of x and g of x, and it looks almost identical. We have f prime of x times g of x minus g prime of x times f of x divided by g of x squared. So anytime we see division where we have a variable on top and bottom, or just a variable in the denominator, we can use quotient rule. So we have this first one. So we have h of x is equal to 2 minus 3x squared divided by 4 minus 5x squared. So just like before with product rule, we're going to do our separate kind of look at what our u would be and what our v would be. So in this case, u is going to be always our top function, the function in the numerator. So in our case, u happens to be 2 minus 3x squared. V is always going to be the denominator's function, so 4 minus 5x squared. And just like last time, we need our primed versions of these, so we are going to go ahead and take that derivative. So u prime, 2 is a constant number, so that is gone. We have negative 3x squared. We can use power rule on that, so 2 times negative 3 is negative 6, x to the first power. Similarly, we have v prime. Derivative for 0, and the derivative of negative 5x squared is negative 10x. So we're going to go ahead and put these together. So I have h prime of x equals u prime, so negative 6, times our function v, so our 4 minus 5x squared, forgot to write the x, minus v prime, so negative 10x times u, 2 minus 3x squared. And then I take all of that, and that is the numerator of v, so 4 minus 5x squared being squared. Okay, this right here is our setup for quotient rule. I have found a derivative, and it is kind of just done. The thing is, though, is that a lot of times when we have a question like this and it's a multiple choice question, it is simplified. So what we're going to do is we're going to go ahead and look at the simplification to kind of see how that might work out. So the first thing that we're going to be doing is multiplying out or distributing these negative 6 or negative 10x. One thing that we're going to do is we're going to leave the denominator as something squared, because a lot of the times we don't actually need to get rid of it unless it matches exactly, and then we can kind of just go with things as we can. So the first thing I need to do is multiply out what I have. So negative 6x times 4, so negative 24x, negative 6x times negative 5x squared, so positive 30x cubed. We have minus a negative, so I can combine these. So instead of saying minus a negative, I can go ahead and say that this is now plus. So I'm going to do that. And then we're going to multiply out that 10x. So 10x times 2 is 20x. 10x times negative 3x squared, so negative 30x cubed. And then we have the denominator squared. So looking at this, I can go ahead and simplify what I have. So I have negative 24x, and I'm adding 20x to it, so we still have negative 4x. I have 30x cubed, and I'm subtracting 30x cubed, so that is realistically all I have in my numerator. So I have this as the most simplified thing I can possibly get. We may want to do this if we have to do more things with our function. If I had to plug something in for x here, I have more x values to kind of mess up than if I plug it into this. So this is more of what a multiple choice answer might look like, but if we just need to write the derivative, this is still an acceptable answer. Okay, we have v of x is equal to 3e to the x divided by cosine. So once we get to things that are more than just an x in the denominator, we kind of have to use quotient rule no matter what. Unlike product rule where we could potentially multiply some stuff out, this we have to absolutely use quotient rule anytime we have more than just an x to a power, even if it's added or subtracted to. So we have to do something with this. So u is the thing on top, v is the thing in bottom. So cosine of x is the denominator, 3e to the x is our numerator. The derivative of cosine, so v prime, is negative sine of x, and the derivative of u is 3 times the derivative of e to the x, and the derivative of e to the x is e to the x, so 3e to the x. So we have v prime of x is equal to u prime, so 3e to the x, times v minus v prime. So negative sine of x becomes a positive or a plus sine of x times u, 3e to the x divided by our denominator, cosine of x squared. So there's really not a lot that we can simplify here. The only thing that they may do is factor out the thing they have in common. So if we look at the numerator has a 3e to the x in common, so they may factor it out to get something that looks like this. The other thing we could potentially do is cosine squared could be written as cosine squared instead. But that's really it. That would be more likely to be a multiple choice answer. And either one of these could be that answer. Okay, this last one. So this last one, we've been working on quotient rule, so we're going to look at it with quotient rule, and then we'll look at it how we've been doing it. So with quotient rule, the top is u, so u is equal to 1. V is equal to x. The derivative of 1, it's a constant number, so it is 0. The derivative of 1x to the first is 1. So f prime of x is equal to u prime times v minus v prime times u, all divided by our denominator squared. So if we were to simplify this one, 0 times x is 0, 1 times 1 is 1. So if I were to simplify what we have at the top, we just have negative 1. We have divided by x squared can be written as x squared. So negative 1 over x squared is the answer to this problem. If we were to do it in the way that we've been doing, the first thing that we would normally do is change what 1 over x looks like. So 1 over x is the same thing as saying x to the negative first power. If I needed to get rid of the denominator, I change it to a negative exponent. So now when I take the derivative, we can use power rule, so negative 1 times 1. And then we take 1 away from our exponent. Negative 1 minus 1 is negative 2. I can rewrite this back to how it looked in the beginning, so this could be 1 divided by x squared. So no matter which way we do it, we're going to get the same answer. So if we saw something like this that really we were having a hard time with the negative exponent, we could always just use quotient rule. The thing with the AP test specifically is that whatever way is the fastest is the way that we kind of want to go with. So for me, changing what it looks like and then using product rule or power rule is going to be the thing that helps the most. It's the easiest, the fastest. Using quotient rule, I just have to remember more things in order to be able to do it. Either one works though.